last talk, I'm happy to announce Beren Atac from Berlin, Germany, neighbor. And Beren she studied in Istanbul, but then did her doctoral thesis in Berlin at the Berlin Brandenburg School of Regenerative Therapies, and is now a postdoc at the Technical University there. And she will also tell us something about in vitro modeling and bioengineering.
Thank you, everyone, for the introduction and welcome here. I hope you still have some energy left to listen before the break. So, okay. So my talk is about in vitro modeling of the hair follicle, and then I have no conflict of interest to declare. Yes? Yeah. So I want to take you back to the origin. You see here a scalp staining of the human tissue, and it's a fibronectin staining, by the way. So the organ we are trying to mimic it has enormous complexity that we cannot ignore, and we have to take into consideration. So we knew what we were getting into, and this is definitely not something easy. But we decided to take baby steps. Like, we will start with the hair follicle only, and then we will increase the complexity over the time, and at least that's the idea. And yesterday Bruce talked about, and today Pantelis talked about the importance of DP. We started, we also concentrated on the presence of DP and its crosstalk with the epithelial tissue of the hair follicle. So this is like the first point we have to take into account: how to make these cells talk to each other, how to make them communicate. So then the next point comes with also with the extracellular matrix. In this case, the matrix of the dermal papilla has a great importance. So for the inductive capacity, it has been shown during anagen to pathogen the extracellular matrix changes drastically inside the DP. So, and we also need to consider in general, as Valerie also mentioned, the importance of the presence of skin around the whole tissue. But yeah, this is like the next step. But now, if we go back to the hair follicle. So the tissue has, we are working with the primary cells for humans, so we need to expand them. It's not just, we can take as much as we want, like we might have the chance from mice. So we isolate the dermal papilla, expand the cells in 2D, which we know which makes them lose their ability for inductivity, or reduce it, say, and also melanocytes. In this case, for this study, we used skin melanocytes, by the way, and autoroute keratinocytes from the hair follicle. So when we expanded them, so we had them in suspension, but we let them condensate under low attachment conditions. So it's like they form the spheres in 3D. And then that's the point where we start to see the changes. Claire would also agree with that, I think. So in the end, we start the co-culture with melanocytes and keratinocytes. Then at this time point, that we call this organoid, or the model microfollicle. So then with this, we reach to the complexity of the tissue like this. So we see an organized structure. And yeah, in the beginning, until coming to this point, we had what I call bulk cultures. So we had the cells and the suspension, and they condensated in the physiological range that they also have in the scalp, like a bit smaller, a bit bigger, but they condensated in the amount we know, the spheres they produce. But we didn't really know how many cells, for example, were in these organoids. So to be able to go into the way to develop an assay, we need to know how many cells are there. So it's like we came with the idea, or we were able to develop the system in a way that we have one organoid per well, and we know exactly how many cells are in these organoids, how many, and the ratio and everything. So yeah, and this really helps going toward substance testing, and this also gives us the advantage to observe a single organoid over the time, day by day, how it develops, and we can also do glucose consumption, lactate production, LDH release, to see the status of the tissue, how active it is. So, and then up to 21 days we can culture these organoids as well. This gives us a long period of time for substance testing, for repetitive substance testing. At this point, we also then decided to make a collaboration with P&G, a scientific collaboration that we did extensive characterization of the markers for these organoids. We could show alkaline phosphatase expression from the beginning at day 7, and during the maturation of the organoid. It is still there, but it gets lower, the expression of alkaline phosphatase. Chondroitin sulfate, which is an important extracellular matrix component for an inductive decator in anagen, is still there when we call the mature organoid at day 14. And we could also show stable melanocyte presence over the time. And then we also wanted to look into the layers we could see in the light microscopy. What are they? So we could also clearly see a distinction between inner and outer root sheet organization among the organoid. So we then also look into in more detail with what type of keratins does it express. Like keratin 75 and keratin 71 has a higher expression over the time, and 85 and 82 gets more organized during the maturation of the organoid. So with that, we even did then electron microscopy, which was, I have to say, was a big challenge, because we have the resolution of an organelle inside one cell, but the size of the organ, the whole organoid is like 200 to 400 micron. So the imaging was a big challenge, and thanks to Max Planck Institute, we got really help. And even though the imaging takes around 18 hours, they really were able to manage through the data. So we didn't see any necrotic structures, and also we could also see the melanin particles transferred. So I will not go into the details, but what I can say is that we could cover like outer root sheet keratinocyte expression, the keratins from outer root sheet keratins, the cuticle, companion layer, inner root sheet, and then medulla, and then we could also show cuticle, matrix, and cortex markers. So I didn't show here all of the ones we looked, but this is at least the parts we could cover. And so what we are looking at right now is a single organoid. What we need to, so this is also the point when yesterday also Cheng Ming mentioned a collective response when we are looking into the, let's say, the scalp. There is the hair follicles have a paracrine signaling in the tissue as well. So then we were thinking, okay, how we can mimic that. We also had a collaboration with Karlsruhe Institute of Technology that they provided us with a special mattress. This is serving us as an interface, that there is a microcavity structure which you see here, like it's like 300 micron in size and has little pores on it. It allows the whole structure to be perfused. So when there is when there is an interaction happening, so this can happen. This is providing the interaction, so like the medium exchange is available in every direction. So okay, we can do single organoids. This is really important. But when we also want to do like collective response, when we want to see a paracrine signaling among the organoids, then this is the way we want to go. And we even have the chance to perfuse this system, which I'm very lucky to work in the lab, which produced a microfluidic bioreactor, which is called multi-organ chip. Is that providing, like, so here you see, like, this is one design that I use. It has it's a closed system, and it has on-the-chip pumps, which allows pulsatile flow like our heart does. So to mimic the whole perfusion system. And then there are cell culture compartments that we can culture actually many tissues, but in this case the microfollicle tissue that we could culture. And this is also possible to combine with endothelium. So the direction is going, eventually we have to vascularize the tissue to prolong the duration to make long-term substance testing. But like, in this case, we start with the endothelium production. So it is like a co-culture with endothelial cells and the hair tissue. So now you are looking into the one culture compartment of in the multi-organ chip at day 0. So there are like 120 of these organoids, and you can see them at day 7. So of course my first question was, can I get the same response in dynamic culture? Will they polarize? Will they form sheets as well, like I saw before? And yes, and we can actually culture them up to 21 days as well. So at this point, we then also wanted to see the markers they're expressing. They're expressing nice laminin 5 in the basement membrane and collagen 4 inside like the DP region, as well as endothelial cell marker, melanocyte markers, and again an organized inner and outer rigid structure with again another differentiation marker, keratin 25. So we are now at the level of single cultures that we are actually started doing substance testing, and now we also have a dynamic model which we are this is still, I would say, in development. We are still working on it, how to make it how to make it really robustly usable for the assays. So we are working on that, and at this point I would like to thank to our collaborators, my home institute, and also group members who worked on this project, also to our doctors who provided us with the primary tissue and to the funding agency. And thank you for your attention.
So, any questions for Dr. Beren or from Dr. Atac or any of the other speakers?
So, I have one question for Dr. Gorin. Andy, I think looking at all the effort you put into developing the second assay, from a clinic standpoint, from a person coming in as a patient seeing a doctor, I think the pluck is much preferable, as opposed to doing something, waiting an hour and then measuring blood flow. I mean, what do you think about the practical use of the test?
So I think from a clinical perspective in office, it's true. The one issue that we sort of had from thinking about a patient flow in this, since minoxidil is just over the counter, at least at the current concentration, it's easier to justify a device that will be over the counter as well. And something like a small laser perfusion monitor is easy to make, I think, enough and compact that you can use even at home eventually. That's our thought process. I think if it proves that higher concentration for low metabolizers actually will convert non-responders to 5% into responders to minoxidil, then I think an in-office diagnostic makes a lot of sense, because you'll be a prescription higher concentration. That's our current thinking.
This is question, microphone number 3.
I have a question for Dr. Ju. You use a couple of wavelengths to irradiate the papilla cells, and the effect seems different. So, what's the wavelength do you suggest to stimulate their follicle growth?
Thank you for your question. In vitro study, 660 nanometer was the most potent in promoting the proliferation of human dermal papilla cells compared to other wavelengths. In terms of Wnt beta-catenin or pathway, only 660 nanometer light significantly increased the MRI expression of all Wnt ligands in this experiment, such as Wnt3A, 5A, Wnt10B. and protein expression of beta-catenin and cyclin D, and the phosphorylation of MARC and ERG. In vivo study 660 nanometer showed positive effect on hair shell pigmentation. So I think, in conclusion, 660 nanometers seems to be the optimal wavelength for both the proliferation of human dermal papilla cells and the growth of hair follicles. However, we also demonstrate here that other wavelengths such as 415 and 810 nanometer also enhance the proliferation of human dermal papilla cells. So especially 830 nanometer light promoted diffuse proliferation to a nearly similar extent to 660 nanometer light. So we hypothesize that linked beta-catenin and our pathway may mediate this different effect of wavelengths than these are in these experiments.
So the red is the best?
So I think 660 nanometer is the best.
Thank you.
Thank you. Microphone number 2, we have a question?
I think number 1 might have been for me.
Microphone number 1.
Okay, thank you. This question is for Beren. What stage of the hair cycle do you think your organoids represent, and what's the readout of your high-throughput screening?
I think that we are able to mimic the initiation of the antigen, and I think around day 21 we could see the cycle is going in the direction of catagen from our recent observations and some marker stainings, and as well as bioplex measurements. So it's like 21 days of the cycle until of the antigen, and then it is going into catagen. But we are not at the level of showing, yeah, we have the telogen and then going into antigen again. We have to see.
Okay, so the antigen readout is a shaft? Does it produce a shaft, or do you have other surrogate markers for?
So the markers like keratin 85 is, for example, the one of the readouts that we can observe as a, let's say, indicator of shaft formation. So in this case, keratin expression as well as late keratin expression are the main readouts here. Time to time we also see some fiber formation, but until we really characterize with mass spectrometry the content of the fiber, and also we cannot really control how often it occurs, and depending on the donor, we see a variability of the fiber formation. I would not take it as a readout.
Thank you.
Thank you, Dr. Wang. Yes. Microphone number 2.
Thank you. I'm Oma Abai from the University of California, Davis. Thanks for those great presentations. This is for Dr. Gordon. I wanted to know about the sulfotransferase assay. Is this something that is widely accessible to dermatology offices around the country? If it is it covered by insurance providers? And if not, how much does it cost the patient?
So that's really a question for Obamacare, but no, it's not readily available yet. We we did the validation verification for FDA for this, but it's not available yet. I don't receive it because it is for androgenetic alopecia, both for males and females. We actually developed 2 separate assays, even though they look the same. I don't perceive it being covered by insurance, but I don't know. It's at Obamacare.
Thank you. So we have, I'm going to take liberty to ask one final question, and then we'll move to our break. Dr. Atac, have you progressed your, I know you set it up as a throughput assay, but have you taken your folliculettes and put them into Dr. Tsuchi's type of a system to see what would happen with growth into a mature follicle?
We didn't do any animal tests yet. I mean, in general, our lab is going away from animal testing. That's the reason we are developing the multi-organ chip. But honestly, the results are really amazing. It looks really promising. It would have been really nice, I have to say.
That's why we made sure you two sat far apart. We didn't want any collaboration. Okay, thanks everyone. It was a great session. We appreciate your attention. I have 2 quick announcements. That dinner tonight is in the Bayfront Ballroom on the lobby. So it's in the lobby at 7. And the posters and the exhibits are coming down at 5:30. So this break is your last chance to take a look at any exhibits or posters. And thank you to our presenters. Thanks very much.